Okay. So pretty much gonna use, so at least for today, the GitHub repo. So I mean for presentation. Anyways, welcome to Reactive Land. We're gonna talk about reactive programming, reactive systems, and we're gonna start with reactive programming. You might have heard about it, you might not have heard about it. I think the ones who are behind their computers already have pulled this or cloned this repository. Okay, so what is reactive? What does it mean to have a reactive system? The best explanation that you can get is here in this link. So check it, read it. It's interesting. It's long, so I won't go through it for now. But what we need to know for today, for the starter, when you do reactive programming, you are relying on a framework to make your code asynchronous, as both of you already mentioned, and non-blocking. And that's the main promise. And that promise means that when there is an I/O in your code, like you are reading something from a file or reading something from a HTTP buffer, like when you get the HTTP request, those reads and those writes are I/O. In a classic way, when you do that, your CPU cycles are blocked for that operations. It means that you're just wasting CPU cycle on your main execution thread for just waiting for something to happen. But when you do non-blocking programming, when you do asynchronous programming, that part will be offloaded to another thread, so to say. And when it's done, you will be notified about the result. This notification can be done in different ways in different programming paradigms. I'm not going to go through it today, but the easiest way is callback. We're not going to do callbacks. Don't be scared, because what I explained is what we have in JavaScript in the old way. And in the old way, JavaScript is known for callback hell. We don't want to do that, so don't be scared. So read this later. I hope you have already read this, but apparently not, no problem. These links are perfect for education. If you go through these links, probably you won't need these lectures, but otherwise, stay with us. About how we're gonna do it. So I'm gonna explain some stuff, and I'm gonna give you some information quickly, and then we're gonna do hands-on code. So since we are already less than 6, it's enough to do it in one group. We're gonna complete some tests. So I wrote some tests. They are not completed. We're gonna complete them together. Each of us gonna be the driver. We're gonna do it in a mobile style. Each of us gonna be driver for one of those challenges, one of those tests. The rest of us gonna navigate. And at the end, when everything is green, the color that we love it, we're gonna create a PR. Later, if you want to add some tests in your time at home, feel free to make PRs. That's actually encouraged. So feel free to contribute to the repository as well. That's gonna be appreciated. So let's go right to our first episode of Reactive Land. It's called Just a Box. We're gonna talk about the box. So if you have a box, empty box around you, just bring it close to have a better feeling to make it more real. So one of the first things that is different when it comes to reactive programming is the style of programming compared to classic type of programming. In the classic Java, we do imperative codes. We write imperative. code. We write in the imperative style, but the style that reactive programming requires or uses is declarative. I don't go through the details that much. What are the differences? The differences are also, you can see the difference when it comes to functional programming and like normal imperative programming. Functional languages are usually declarative. That's just extra information, but you can see the difference here. It's very clear what is declarative and what is imperative. And we have it in the classic Java, basically. It's not reactive. So in the usual Java, in the classic Java, if we want to check if something is null and do something if it's null, we do a if, we do a just say we write if and the condition is if something is null, and then we return. But a declarative way is more like when you use optional. So there is no if, there is no check for null. We declare that that we want to create optional, and this optional is a box that wraps the results of this call, this method call. And if this is null, we do something else or else get. There is no explicit if. The if statement is somewhere down there in the layers below this code. You're gonna get a better feeling about this difference later, but from the look of it, this is the difference. We don't do if, we don't do while. We try to avoid this type of codes in the declarative way. The other thing that is a big difference between classic and reactive is what I said previously, it's that reactive is not blocking. So here in this example, this is an example from a blocking code, classic Java. We have a database connection, we send a query to the database, it goes over the network, and it returns something, let's say X. And here we're gonna call that a find by ID that returns the results of this query. So optional is blocking, also it's declarative, but it's blocking. So when we write this code, when it gets executed, the CPU waits here. The CPU, that thread of CPU is blocked before this returns something, before this code returns something, means that before this returns something. So the IO all the way over the network and reaching the database, or CPU is just, CPU cycles are being wasted for that. And yeah, that's blocking programming. How else we can do it? Well, we can do reactive programming. And if we do reactive programming, how it would look like. So we have this optional. This optional is a box that you can put something in it and check if it's null or not. It's just a wrapper. It doesn't have any meaning itself. It's just a wrapper around your data types. So there are data types in reactive programming. We have publisher, we have mono, we have flux, and a bunch of other stuff maybe. We start from mono today. And the reason that I start from mono is that I just want to start from somewhere. And if the space of reactive programming is complicated and complex, I just start from here, and then later, based on your feedbacks and based on what you know, what you don't know, we gonna correct path and find out what's the next step for us. But mono is basically equivalent of optional, but in the reactive world. So optional is a box that you can put one thing in it. It can be empty or it can have something in it. But mono is a box that you might have something in it in some time in future. So it's like you have a box that you expect that some point in future something will appear there. Something will be there. It can be also empty as well, in the same way that optional can be empty. And it's the reactive way of having a wrapper for one thing. I guess I repeated that one thing enough because this mono is only about one thing, and later we can see why this matters. So here you can have a reactive connection to your database. And now instead of returning X right away, it returns a mono of X. So it returns a box that at some point one instance of X will be put there. And when we call this method, we still have a mono, and it's not X. We can't use the X right away, but you know at some point there will be one instance of X in that box. So far it was about differences and data types and comparison and the basic idea. So now we're gonna talk about the APIs, the methods that are available in the reactive programming. So the first thing that comes to our mind is that, okay, we know how to create optional. We can do optional.off nullable or optional.off. But how do we create a mono? The easiest way to create a mono, to create a box, to create a reactive box, let's say, is to use just. It's a static method. You do mono.just and you put something there. So you have a box that you know there is something there. In a real code, you rarely use this, but that's the way to call it. That's the way to create a new mono. So, and mono is generic. You can give it types in the same way that optional is generic. You can give it types. So yeah, if we start our day with just today, and it means that mono, yeah, I want a mono that just have this one right now. And yeah, it will be a box that has a T in it. An instance of this class called T, whatever it is. So this box, there's something in this box, how we can actually get access to that thing, or we can actually use that thing. You can imagine that this box has a tap. It's like, imagine there is one drop of water in that box, and you want to get access to that drop of water. What you do, let's say you connect a tap to that box, and then you open that tap, and then that drop will get out of the box and you can use it. This drop of water is your data. It's the one thing that you have put in the mono using the just. How to connect the tap to your mono? The method is called subscribe. So when you have an instance of that mono, you can do a mono.subscribe. That's the simplest way. So here you get the drop, the actual data that is in it. But it's not like this T will be available the moment that this code is executed. That's the blocking way. But in the non-blocking way, you say to the framework, to the execution framework, that whenever a T was available, do something. It's not like your code stops here until T is available. Your code will be like, imagine like this, you submit your code to some space somewhere that you don't know about, but that space will execute your code the moment that T is available. So yeah, you open the tab, but the drop comes out of it whenever the drop is there. You don't know if the drop is up there, and you don't wait there. But actually, there is a way to make your code stop there. Make it like a classic Java code. So if you want to get access to whatever is inside the mono, right there, you use block. You do mono.block, and then your code stops here until whatever is in block is available, and then you get it, and then you move to the next line. Remember, this should not be used in production. It's just for understanding the concept, and you can use it in test, but you better not. So yeah, don't use this in production, but we're gonna practice with it today. And let's talk about tests. So you can do .block to get something out of the mono, and you basically assert it to see if whatever is there is what you wanted to be there. But there are actually reactive ways of writing tests as well. There is something called a step verifier. And when you create a verifier using a mono, you can now do assertions and define expectations on that mono, which is reactive way of testing. Here, like you can write a lot of stuff here. It's just an example. So the create part is mandatory. You should put this at the end of your tests. You create a step verifier using that mono. And now you talk about your expectations. You expect that at some point, there is something in that mono. So expect next means that there is something there. But you don't know what is it. You just verify that there is one value in that that box. You can do assert next. Now you are actually doing an assertion against the thing that is there. If there is something there, you will have it here. I called it next. You can call it whatever you want. It's a lambda. So here you should write the you should return Boolean in this lambda, which means that the predicate that defines your assertion, the thing that you want to check. You can check if this is equal to what you want to be, and you can verify at the end. Don't mind about this now. We're gonna talk about this more later. But to make me fast, to say something quickly is that if everything goes fine, your mono at the end of the day will complete. So you should expect your mono to be completed as well. And then verify is to verify everything that you wrote here. So this is how you test. I hope I was not too fast. This is all we gonna have to work with for today. And let's bring up our IntelliJs if you use IntelliJ or whatever IDE that you have. And then open this file, justthebox.java. And you can use the README. I'm gonna do the same. Gonna share my other screen. So, okay. So this is just a test file in the test directory, season 1, episode 1, just the box. So, are we there, everyone?
Yep.
Okay, I'm gonna stop recording now.
I think I need to set up a plugin to get Gradle working.
You have a, yeah, if you, the Gradle is, so the Gradle is here actually. All you need from Gradle is here. But your IntelliJ might not understand. By default, it should, because it's by default part of the plugins that is there in the IntelliJ.